Good morning, good afternoon, good evening, everyone. We are now live with our session on MongoDB CDC with Confluent and Tinybird. My name is Jim Moffitt. I'm a developer advocate here at Tinybird, and I have a special guest, Cameron, who's going to join me as a co-host.
Who's getting his camera set up?
Yeah.
There we go.
I was going to say, my fellow developer advocate, April, who I think normally would be joining me for these sessions, she's off at the current 2024 show in Austin, Texas. So the topic and the subject matter for today is quite fitting. We'll be working with a Confluent Connector to pull MongoDB data into a Tinybird instance. So cheers to everybody at the current 2024 show.
It should be fun. It always is. I'm excited about the crew we have there too.
Yeah. Today, obviously, the topic is MongoDB, and I'm just sharing some results from the latest Stack Overflow annual survey of different tech stacks. And here's a closer view, and you can see that MongoDB is in the top 5. And of course, MongoDB is a NoSQL database, a lot like DynamoDB in that sense. Last month, I did a session on Postgres, and it's interesting switching the headspace that you use when you're working with a relational database like Postgres, and then switching to a NoSQL data store like MongoDB. So, this session today is ideally for folks who are storing data in MongoDB, and you are in a position where you want to build live real-time analytics on top of it. Maybe you've already tried it with just pure native MongoDB solutions, and you may have found challenges in many ways. One top of mind challenge may be on the front end, where you have hundreds or, depending on how many users you're building for, maybe you have thousands of concurrent requests. And what we're going to do today is show how to bring MongoDB data into Tinybird. And if you're not familiar with Tinybird, that's great. I'm going to have a few minutes soon. I'll give just a brief overview of all the things that Tinybird is. But essentially, it's a real-time data analytics platform. It makes it super easy to bring in various data sources. Did a session last month on Postgres. Today's MongoDB. It has native connectors for Confluent Streams, for Red Panda. There's a long list, BigQuery, Snowflake, etc. So once you bring these data sources in, you can transform, join, aggregate that data using SQL, and then you can publish them as API endpoints. So again, if you're new to Tinybird, we'll give a quick overview in a second. The topics today. One, we'll be publishing MongoDB data to a Kafka stream. And to do that, I'm going to give a quick tour of a MongoDB collection I've set up on Mongo Atlas. And then we will briefly visit the Confluent MongoDB Atlas source connector. That is the piece that will read the CDC op log from MongoDB and stream and publish them to a stream, and then using the native Confluent connector, we will then pull that data into Tinybird. So again, we'll show the setup of that connector. We'll be subscribing to a specific topic that is set up as a result of our Confluent source connector config. And then we'll publish some API endpoints to publish that MongoDB data. And that's really kind of sums up the big picture here is, like, if you're looking for a way to publish your MongoDB data as a real-time data product, as an API, then I think what we're showing today will be pretty relevant.
And Jim, I think it's important too to call out that, the reason that you would want to get this MongoDB data into Tinybird in the first place is that, MongoDB, or rather I should say Tinybird, is very well suited for these real-time analytics use cases. It is a, columnar data store really built for the kinds of things that would be a little bit more difficult to do in MongoDB.
Right. Right.
And then I also just want to add, the approach today is a really solid approach, and Confluent does a lot of the work here to get that data into Tinybird. But we might be coming out with a little MongoDB connector sometime in the near future. So you
Yeah.
didn't hear it from me.
Right. Right.
Keep your eyes peeled.
Yeah, and that's really the beauty of all of our native connectors is they kind of abstract away a lot of the fiddling, the wiring, the configuration. So yeah, I as a developer advocate really look forward to more native connectors in that regard. At a deeper level, we're going to talk and address like how do you manage these CDC events that are coming in the Tinybird. There's really 3 different events that I'll be talking about. One is these insert events. That's when new data arrives in the MongoDB collection. They get forwarded via this stream in real time. But of course, there's also delete and update events. One of the challenges, at least in the data generators I typically write, in some cases, I end up with duplicate data. Often that's by design because I want to be able to illustrate how do you manage duplicate data. It's a very common issue that I'd say most of our customers run up against once in a while. And it's, of course, critically important when you're doing aggregations, maybe you're doing some statistics. You don't want to double count any of your data points. I'm also going to show working with nested JSON objects. I mean, that's really the beautiful thing about these NoSQL databases is that you can literally store totally different documents in one table. And we'll walk through an exercise that illustrates that. And also related, of course, is not only are these JSON objects nested, but again, you can have totally different types of objects, types of documents that you're pulling in. So what is Tinybird? Again, if you're new to Tinybird, here's a quick 30-second elevator pitch for all the things that Tinybird is in my mind. One, it's an OLAP database. It has an OLAP instance. It has an instance of ClickHouse as its data layer. So many could think of Tinybird as a managed ClickHouse instance. We abstract away all the challenges of scaling and deploying and keeping your ClickHouse version updated. In fact, we are one of the major contributors to that project. And in fact, Cameron has recently posted some blog posts about how we are basically managed ClickHouse and what the comparisons are. I don't know if you have any color commentary to add to that. But
I would argue that we are not basically a managed ClickHouse, but that the storage and compute engine underneath Tinybird is ClickHouse, or is at least based on the ClickHouse open source project. Tinybird's a lot more on top of that, and actually, we can litigate that later. But I think the important thing here is that ClickHouse is kind of that underlying storage and compute.
Yeah, and that's very fair. Yeah, I'm talking about just the data layer itself, and then yes, Tinybird offers all kinds of functionality on top of that, which we will tour today. It's also, I see it as a platform for unifying data sources. I kind of mentioned all the different sources where you can bring in data, but it's an amazing platform for bringing in data from everything. You may have a Snowflake instance. You may have stuff on S3. You might have BigQuery tables. You might have streams, hopefully have streams, because I feel like Tinybird really shines when it comes to this truly real-time data. It's also, of course, a data analysis platform. You bring all this data in to join it, to filter it, to aggregate it, and you can use your SQL, SQL skills to do this analysis. As part of being this built with ClickHouse, that brings its own special, powerful dialect of SQL, especially if you're working with time series data. There's all kinds of amazing Windows functions that you can use directly in Tinybird. And of course, you do all this analysis. You're building these data views, and then once you're happy with your data view, you can literally push a button and you deploy an API. You can use Tinybird to build these endpoints of your API. You can blend in dynamic query parameters, etc. All right, so here's a quick view of what we're doing today. And this kind of highlights just the three components that are involved. We have our Mongo Atlas collection. I have a weather data database that's up there. It has a couple collections. One is a site metadata table, but more importantly, there's a weather reports collection. And I have a Python script running that is loading that collection with live data. Behind the hood here, I have a Tinybird instance, a workspace instance where I'm pulling in live data from Open Weather Map. And I'm actually pulling data from that Tinybird instance, turning around and pushing it to Mongo. So not a normal setup, but I have this live production data source. So I'm utilizing that today and have the script running. It runs about, I think, every minute, looks for new data and pushes it to Mongo. So let's go look at Mongo Atlas. This is my dashboard. I set up a database there, and then I have these different collections that I mentioned. I'll just spend a few minutes here. I have this weather reports collection. That's the one that's getting live data. And I can see currently it has 231,000 documents in it. I think it goes back to early September. I did not load the whole data archive here. If I had that, it would have had about 12 million weather reports. And just some background there. These weather reports, they cover 175 cities, the most populated cities around the United States. And for each city, data comes in about every 10 minutes. So overall, with the feed, data trickles in every minute or so. And then let's jump over to Confluent. So this is where my data is hosted, and this is the piece that the collection that we want to pull into Tinybird. And the way we do that is with our Confluent connectors. I have one set up and running, and I'm not going to mess with this one because the main reason is it is managing a stream that has already had many thousands of documents already published to it. But if you were going to sit down and do this from scratch, if you go and set up your cluster, and then once you do that, there's this connections or connectors tab. And maybe I can make this bigger. But they have, of course, different flavors that you can pull data from and publish it to a stream. I'm going to be working with the Mongo Atlas source connector. I'll just spend a minute here on this UI just to give you a look and feel for how it works in case you haven't used it. Important thing is a topic prefix. I'm going to call mine weather. No, I'm going to call it something else. I'm going to call it MongoDB. And how this comes into play is that when you do publish these, it goes to a topic on a Kafka stream. And the topic that you'll interact with will start with this prefix. The rest of the topic would look something like dot, and then my database is weather data, and then my collection that I want to publish is weather reports. So that's what the topic would look like. But at this stage, you just put in what your prefix is going to be. Hit continue. I'm going to run it on my account. You have to, for this, you'll be generating keys. I'm going to continue past this. And then this is where you would configure your connection details to your MongoDB. And of course, I just got logged out of Google. Bear with me. Actually, I'll just pass through this. But anyway, this is where you put your host of your MongoDB. You'd put your username and your password, the database name you want to hit, and then the collection name you want to hit as well. And then once you do that, you should have it up and running connector. I'll go back to the one that I have configured already. I'm going to go back. It's not letting me. Anywho, let me log back into Confluent. Now I can't seem to type here. Jeez.
My typing always goes to crap.
Yeah, I don't know what's going on here.
Know exactly how that feels.
Something went wrong. Verifying it's you. I don't want to do that either. Bear with me. I have to log back into. All right, back on the road. Bear with me here. So now I can probably get back into Confluent. All I'm going to show here is quickly, I'm going to log in. Okay. Back on the road officially. So if I'm going to go to our cluster here. And I'm going to give a quick 30-second tour of this connector I already have set up. We'll click into this. I named it Mongo Weather Data. One important thing here that you need to do is when you're accessing your data in Atlas, you have a long list of IP addresses that you have to allow into your Mongo instance. That's probably one of the most time-consuming parts of this setup. And I will say that I don't love the UI for entering these IP addresses in Mongo Atlas. If you go here, over the weeks here, I've added lots of different IP addresses, and it's not the best UI in terms of sorting by either the comments or the IP addresses themselves. So anyway, where we are right now is we've set up this Confluent connector, and now again it's publishing all of these events coming from Mongo onto the stream. So now let's go to Tinybird and let's ingest that stream. And the way I'm going to do that is I'm going to go here for data sources, and I'm going to hit that I want to add a data source, and I'm going to add a Confluent stream in this sense. Now I'm going to look up my credentials here now that I've
And while you're doing that, Jim, I'm just gonna throw this up. So Jim's walking through the Tinybird UI. All these resources are defined in code, and so I've linked to the repository here. If you want to go look at that code in GitHub and just see what this all looks like,
Cool.
You'll find it there and at that short link. So I'll leave that up for a little bit.
All right, and before I jump into the configuration, I just wanted to highlight here is a good view of the different native connectors that we have. I talked through many of these as an example, but let's go to the Confluent one. Now for here, I'm going to put in my server for my stream, and I'm going to call this one Mongo CDC events. You can give it any name you want. Now I'm going to go and add a key, and then my secret, which is the things you generated with the Confluent interface. Let me hit next. I'm going to search for the topic that I know I'm publishing on, and again, that's the prefix I added. Then my database name, and then the collection name. I'm going to select that. And now here you have an option. You can bring in just data that's been published, like since you set up this connector, or you can go back and get all the records that have been published since you started the Mongo Atlas source connector. I'm going to pick them all. And I'm going to call this the Mongo CDC events data source. And what you see here is we're already pulling in data, gives you a sample of what's in this stream. And you can see there's all kinds of information, including, what collection is being reported, where the database is coming from, what type of operation. This is important. And if I look at, another important thing is choosing keys that you want to set up as sorting keys. And here I'm going to be looking a lot at the document key. This is important for looking up, especially when you're handling deletes, because there's no, it's a long story, but there's no payload provided with it from what's Confluent is providing. But every update that comes in, every event that comes in does have this document key. So you can set up different sorting keys here. I know in the end, I'm going to be pulling data by timestamp. I'm going to be pulling data by site name, maybe, things like that.
And I just want to add here too. I mean, if you're coming from a MongoDB space, you're dealing with a NoSQL kind of very different data structure, dealing more with like, probably a lot of JSON structures, semi-structured data or unstructured data. So Tinybird has much more of a structured approach. But one of the nice things is there's a lot of tools within Tinybird for handling JSON. And so like actually a common approach that some people will do is just take, all of or a large portion of that MongoDB payload and just dump it into a JSON object in a single column and then sort of denormalize it later. So there are a lot of good strategies for sort of handling unstructured and semi-structured data in Tinybird. And what Jim is showing is kind of the classic way of structuring that data on ingest, but there's a lot of ways to do that denormalization.
Yeah, and that comes into play here too. What I'm showing here, and this is for any new Tinybird user, under the hood, these data sources they're basically config files, .data source files. And this is what our system came up with just by looking at what was presented off the stream. But I don't really want to run with these. For one, like I don't want attribute names that are this long. I'd rather just have a humidity object and a description object, etc. But to speak to what Cameron was just discussing is if I'm going to instead, I'm doing my own custom configuration here for the data source. And the highlight here is that I'm going to be pulling in the full JSON document, which in the stream is referred to by full document. I'm going to make this a little bit bigger. So what I'm saying here is like this document, I want to just hold that in an attribute called payload. And that will be a JSON string basically that I can then parse and get to my underlying attributes in that document itself. Again, those are weather attributes, for example. There's be a temperature and there's going to be humidity and all there. There's like 8 different parameters. Another thing I'm doing here is from that document, I'm pulling in the site name and timestamp at the very top. I'm always going to want to access those. And in this case, I don't even have to parse that payload JSON to get it. So I'm going to create this data source. And I got an error. That worked perfectly before. Okay, I still have my connection here. Let's go in again. And again, I want the Mongo. All right, so let me go straight to this code editor. And I'm going to copy in my schema. Gonna check a few things here to make sure everything looks okay. I'm not sure why that failed. It says here, it's been importing data since I first started this stream in Confluent. All right, I don't know what I did differently there, but it worked fine that time. Again, I'm going to call this data source Mongo. All right. Yep, I want to rename it. Okay. So here you can see it's already pulled in over 100,000 rows of that data. And meanwhile, another thing I can do is I've set up a playground to just explore these type of things. And I want to do a count on that data source. Yep, I have 107,000. How many reports do I have? Okay. Another interesting thing here is I'm going to see how many deletes have come in. And then we'll start talking about how do you manage those. Oh, I haven't set that up yet. So let's go back to that data source. And you're going to notice something here. I've set up this schema. You can review it here. And again, I have this payload that I'm loading in the JSON object. But I've learned from the Mongo CDC system, when there is a delete, there is no payload. It comes in as a null value. So you do have the option to make this field nullable. So that means even if there's no payload, it'll still ingest it just fine. The issue with that, though, is once you have this payload that's nullable, anytime you try to parse out members of that payload, they will also inherit that nullable attribute, which isn't ideal because then you can't set up these attributes as sorting keys, which I'm definitely going to want to do. But one thing that I've done here is now I'm going to set up a pipe, which is going to extract those delete events. And again, those are the ones that are don't have the payload for a weather report. So let me set up a new pipe to do that. And then I think this will make more sense as we walk through this example. So I'm going to start a new pipe. I'm going to call it feed deletes MV. And then we're going to add a node. So what these pipes are, they're a collection of one or more nodes. And in these nodes, you put in the SQL that you want to use to aggregate, to filter, to join your data. So I'm going to call this first node get deletes. And what I'm going to do here is a little different. I'm going to select document key, because that always comes in with deletes. I also want to do the insertion date. And this is the twist. I'm not pulling in from that. I'm going to pull in from the Mongo CDC events quarantine, because I know that all these delete events are showing up there. And also what I want to do is where there's an operation type that comes through, and I'm looking for delete events. So let's run that. All right, so here's a good look at what that brings back. The key thing here is this document ID, and why this is important is because in a minute we're going to be joining any data extraction from these Mongo CDC events. When we pull weather reports, we're gonna join that with this table so we can knock out anything that's been deleted. And to do that, I'm going to create a materialized view here. And I'm going to base on this get deletes node. There might be one or more nodes here. Here I just have one. So let's do this again. The sorting key, that's fine. Actually, both would be good. Here's the advanced tab, and I'm going to hit next. And I'm going to call this just deletes. This is a new data source that this is going to create. And here you have different options for what you want to bring in. I think I only have like 6,000 deletes out of this 100,000. But let's pick this one. I'm picking up. This would be an option for if you don't care how much data is in that stream, you want to pull it in. And let's go back. This is what I had set up. All right. So there I have this new data source. And what this will contain is all of the deletes that have happened. And now I'm going to build another pipe. Here we got the 6,000. So these represent all the data that I have ever deleted from this data source on the Mongo side. Now let's set up a similar thing for the weather reports. So I'm going to set this, I'm going to call this feed reports MV. And let's set up a node. This one I'm going to copy in because there's a lot of typing here. But we're going to call this node just to kind of explain what it's doing. It's getting reports and it's parsing the payload. And I'll show you how you do that in a second. And this is kind of where it gets interesting, where you start getting into the JSON string that you've extracted out of this source. So I'm going to do things like timestamp. That's at the highest level of this report coming in. I also want the site name. And then this is where you can use these. There's a set of JSON extraction functions. I'm going to use string in this case. No, I'm going to do a float because I'm going to pull in. And here I'm referencing that payload attribute that's coming in with these reports. And I want to do temperature. There's a field in there in that JSON called temperature Fahrenheit. And I want to do this as temp F from deletes. And the other thing I want to do, I want to pull this in from the Mongo events table. But in this case, I want to pull in where the operation, or just a second. And here, I'm going to copy in some of the other things that I need here. So this is the full view of what I'm parsing from that payload. I'm bringing in a description, a temperature Fahrenheit, a precipitation, humidity, clouds, pressure, wind speed, and wind direction. I'm also pulling in the document key that relates to each report. And the reason I'm going to do that because we're about to join with that delete, that materialized view of deletes. So the way I do that is I'm going to do a where clause here. And what I'm doing here is pull in every document from this Mongo CDC events table where that document key is not in our deletes MV. So let me run this. So what this table now represents two things. One, here we have a nice clean table that we can write all kinds of queries against. We're going to be building some APIs to pull from here. But what we have here is a very clean look at this data. It's got timestamp as a date time field. It's got the site name and then the long list of different attributes. So I want to create a materialized view from this. And I'm going to call this the reports MV. meaning this is the clean list of non-deleted reports that have come in. And let me let's see, sorting keys. Sorting keys are important for keeping your queries quite fast. In this case, I have a sense of how I want to pull data from this data source. And namely, that is timestamp. I also want to pull in by site name. And for what I'm building, actually, the temperature is probably the most requested attribute. So I'm going to set up those three. Another thing I'm going to do here is I want to set this up as a replacing merge tree. What that means is if duplicates do arrive in my source CDC table, this, as things get written to this reports MV, as I pull data from here, I can use a keyword called final to always get the latest up to the second view of not only the large archive of data that we've already packed away, but also any pieces, segments of data that have arrived just over the last few seconds that have not been merged into the full archive table. So let me do that. And again, I'm going to do this option. Actually, I'll do this option. I don't have anywhere near 2 million rows. In fact, here it tells me I have 108,000 rows. So let's create that materialized view. All right, and you can see that here. So again, what this table represents is the clean view of all the data that I'm pulling in from MongoDB. And let's go take a look. I've set up another playground. What playgrounds are, they're just a really handy place where you can start curating SQL. You can experiment with your tables. In this case, I want to look at the most recent data I've pulled in from the MongoDB database. And you can see here, roughly 3 minutes ago, I got data from Orange, California. But it just shows you as data gets put into that MongoDB every few minutes, it shows up here. And this latency I'm measuring here is really a factor of the source data, again, only trickles in every couple of minutes. And then I have that script running, this one, I'll show it again. This one that's pulling data and pushing it into Mongo, that runs every minute. So you're gonna, in this case, in this demo, you're gonna expect a few minute latency, and here you see a 3 minute latency. So that's well and good.
Hey, Jim.
Yeah.
We had a question. I'm not sure if we have the answer to this, but a question about kind of what is the bottleneck from the Mongo side for this streaming. I'm actually not sure what the answer to this question is off the top of my head, but I don't know if you have it here.
Yeah, my sense is that if I had a more real-time feed, like say I was pulling in data every few seconds and writing that to Mongo, that process is actually quite fast. If I had 10 different scripts pushing to Mongo, that might get a little contentious. But in my case, where I have a single stream, that doesn't seem to add much latency. And then once it's there, my sense is that op log, which is what Mongo maintains every time there's a change, that gets written essentially in real time. And then from there, you're doing quite well. You're publishing that in real time to a stream, and then on the Tinybird side, you're pulling that in with really no added latency. So my sense is that if I had a true real-time stream, these latencies that we're seeing here would probably be just maybe a second or so. My sense is that it's quite fast. So back to building with Tinybird. So what we have here is we have this CDC events coming in. We're handling the deletes. We're using materialized views to set up a table that's just about the deletes. And again, those deletes have a very limited view of metadata to work with. The main thing being this document key. But we're also maintaining this reports that is, again, the product of merging, of joining with that deletes table to come up with just the data that hasn't been deleted. In fact, probably do a little experiment here. Let's go back to the playgrounds. And I have one that's about counting deletes. Where is that? No, I'll just write it. Here we go. But this I want to change to, I'm doing a count from that deletes table. Okay, so right now at 5,600. And what I'm going to do is I'm using the Atlas Mongo Atlas CLI tool. And I set this up. I'm going to delete all weather reports that have ever been published for Gilbert. I don't know where Gilbert is. I'm sorry to the residents of Gilbert, but I'm going to go in and remove from Mongo all your readings. So I'm going to do that. And it tells me, all right, I just deleted 1,253 records. So now let's come back here and run this again. And you can see they're already there. So that is an example of a CDC event originated from Mongo, going through the Confluent connector and showing up in Tinybird within seconds. So that's great. Now, let's continue back in Tinybird. What I'm going to do now is set up a most recent pipe. What this is I just want an endpoint. Well, let's build it first. I'm going to build a pipe. I'm going to call it most recent. This will be a quick exercise. Let's run this thing. And it's my convention and that of many others. I'm going to be publishing this as an API endpoint. So I'm going to call, in this case, I just have one node. I'm going to call it endpoint. And then I'm going to do things like, I'm going to copy this in for the sake of time, and then I can walk through it. So another little nice feature. You can hit this special format, and it'll make your query look more pretty. So what I'm doing here, another thing, I need to select this to reports.mv. And because that's a materialized view with the replacing merge tree, I want to set up this little final keyword. So every time I hit this query, it's going to automatically merge all the different pieces that we've been maintaining as new data came in and blend it in with the full corpus of data. What I'm doing here, it's kind of what we saw before. I'm grabbing the timestamp, the site name, the temperature. I'm also looking at the latency here. The special sauce here is what I've done is I'm using let me zoom in a little bit. I'm using our templating language to add in a dynamic query parameter called city. And what that does is it goes in and tests if the site name is equal to what the user has passed in. So let me run this just to make sure everything is good here. And let's see what our latencies are again. Okay, about a minute ago. That's pretty good. That's about as fast as I could expect, given that I have an underlying script that runs every minute. So this is one of the beautiful things about Tinybird is I've now set up this pipe, and it's giving me the results I want and that I want to share. And I go up here and I create endpoint, and here I'm selecting the node I want to publish. In this case, we just have one. And there we go. I have this most recent endpoint. A couple things. It already, it parsed my SQL and came out with this available parameter. Now I can do things like, here's example usage. It shows the results coming in. You can see what our APIs look like. They're just standard JSON objects that are being served. I'm going to reduce my screen. Now I'm going to copy this URL and go to the browser. And here is this endpoint. And a couple things I could do. Remember, I set up a city parameter. So I can come in here and say something like city is equal to, let's go to Austin, Texas, where our colleagues are, and see what's going on down there. I, by the way, am sitting here in Colorado. So there I use a dynamic query parameter of Austin, and you can see it's filtering accordingly. And right now it's 82 degrees already down in Austin. Another quick thing I want to do here is I'm going to add another pipe, maybe doing something a little bit more interesting. I'm going to call this daily stats. As you can guess, probably do some aggregations here. And let me prepare for this. Okay, I'm going to call this one get data. This is the first node. It just has a simple job of getting the last 7 days of data for our analysis. I'm going to copy in the SQL. I'm going to prettify a little bit. Okay, so what we're doing here again is we're grabbing the timestamp and the site name. And again, I changed the name from when I first set this up. We're pulling from that reports materialized view. This is important. I'm just bringing in data from the last 7 days. And again, I'm supporting this option to include a city of interest. So I'm going to run that. So that's our first node. Now let's go down to our second node. This is, in this sense, building these pipes is sort of like a Juniper notebook, a Python notebook, where you can, if you have a very complicated query in mind, you can break it into logical pieces. And I use that functionality all the time. It helps me just think through the transformations I want to perform. So now I have this second node called endpoint. Let me grab some SQL to share and talk through. You can see that this one is pulling, here, let me zoom in again. We're pulling in from the previous node that I called get data. What we're doing here, this is a kind of a special thing. We're using this function called start of day. That is from the underlying ClickHouse dialect of SQL. And I've found these type of functions amazing if you're in the business of wanting to bin your data, your time series data. In this case, this simple function call is going to aggregate and create daily bins of my data. And then when it's doing these averages, mins, and maxes, it's applying those to those buckets of data, those daily buckets. So let me run this. And here you see again, I'm doing some statistics here. I'm looking at daily averages, mins, and maxes. And again, and you could, to make it hourly, I could do something as simple as, let's do hourly to start of hour. If I run that, you can now see, I'd have to change the format here to show the hours. But anyway, just a quick example of how you can use these functions to generate and work with bins of different sizes. You could do monthly totals, you could do daily statistics, you could do hourly statistics, what have you. So let me create this API. I wanted to pick that last endpoint. And here we go. Here we have an API. I can prove it. Let's take that again to the browser and see this in action. And there we have our daily totals. So, all right. Now, okay, so what we've covered so far is handling these CDC events. We've shown that, like that example for deletes, things propagate through the system to Tinybird within probably less than a second. What I'm not showing today are updates, but they kind of follow the same pattern as what you do for deletes, in that you would parse that data from the incoming feed, and you would build a materialized view that contains, again, just a view of what update events have arrived. And then when you go to serve your final data, you would blend in that data into your results to reflect the recent the most current state of that updated record. So now we're going to switch gears, and we're going to talk about working with nested JSON, and then also working with different types of documents. So to do that, I want to bring in one thing. This is another JSON script that I'm running. In this case, it is streaming data to our events API. I'm not, for this exercise, I did not use Confluent, but I'm generating nested JSON and sending it to our events API, which is kind of a catch-all API. If you have a data source that maybe doesn't live in any of these hosts that we've talked about, you can use the events API basically to stream your data straight to us. So I'm going to start up this script and we're going to see what happens. So it's starting to stream data in, and because of that, we should see a new data source, and in fact, we do. And in my code, I told it, send data to a nested JSON data source. And I'm doing this just to show a couple things. One, if I go look at the schema, and again, this was all automatically inferred by the Tinybird system. You can see, oh, let me show you one thing to help give us some context. These are the different types of JSON objects that I'm sending in. I have a report, an event type equals report, and an event type equals alert. And you can see here I have this nested JSON for the wind parameters. I have another level of speed and direction, for example. And you see that these objects have things in common. They both have an event type. They all have timestamp and site name, but their messages are quite different. So let me go back to, and you can see what it did here is it automatically flattened our nested JSON. It got a reports object and it just acted on that. You'll see that it flattens the JSON by, I had a message object inside there. I had a humidity, but you'll notice down here it also flattened the nested aspects. It has a message object, then I had a win object, and under there I had a direction, and I also had a speed. Now this is well and good, but this is basically hard coding that schema. And if I start sending in alerts, which have many different message attributes, they'll all be thrown in the quarantine. So that's not really what I want. What I want to do is, like before, I want to build my own custom schema. So I'm going to delete this. Well, first, let me kill that. All right. So now I'm going to go and delete this. And we want to make sure I'm deleting the right thing. I am. So what we're going to do now is we're going to go and create a data source. And there's an option here to write your own schema. And that's exactly what I want to do in this case. So let me go grab the schema I want to work with. And you'll notice some differences here. So let me copy in all this. So what you're noticing here is, again, we have this payload field where I'm, whatever that message contents are. And again, I have these different objects that have different message bodies. But I want to bring in the event type, that's the timestamp, the site name, but then everything else I want to pull in as this JSON. So let me do that. And you'll notice there's no data coming in because I haven't started my feeds, which I'll do in a second. And I'm going to call this data source nested JSON. And let's create that thing. Now let's go back to our generator. And we'll clear this. So again, now I'm going to be sending in these nested JSON objects. And now they're flowing in. And another thing I want to do is I have a separate script that's going to be sending in these alerts, which again have a different JSON structure for the message component. And this thing's much slower. I'm trying to make it more realistic. It just sent in one alert. These alerts will probably show up every minute or so. So let's go back to our thing. One thing I want to do is, this is a new feature that we just added a couple days ago. I'm going to add, because now I really have like 2 different projects in here that I'm working on. I'm going to create this tag. I've set that. That's the only thing I need so far. Then I can go up here and I can say, hey, I just want to look at this stuff. All right, so now I have a different view. I'm just looking at what we're looking at now. So let's continue with, now I have this feed coming in. We have different JSON objects showing up. So let me build my first pipe. I want to create a pipe. I want to add this as part of this group just for fun. I'm going to call this feed alerts MV. And let's set up what that looks like. So what I'm doing here is I'm selecting that timestamp, that site name. I'm extracting the payload, and I'm grabbing that message. And again, it could have different forms. I'm then extracting the expire time from that payload. All these alerts have a expire time when the alert will expire. I guess that makes sense. And the source, I'm grabbing it from that nested JSON that has a blend of these documents, and I'm only pulling in the event type where it's an alert. So I have 2 so far. Now let's create a materialized view. I'll just leave that name as it is. And let me check one more thing. All right, so we got here again, I should pay attention to my sorting keys. Timestamp, site name, and message all sound good. Let's go to the advance. I am going to do this replacing merge tree just in case my source is sending me duplicates. I'm going to create that materialized view. And I need to go in and clear that because where is it? Feed alerts. What I want to do is, oh, here it is. I do want to change the name of this to alerts.
Jim, while you're doing that, I'm just going to share next week. Jim is actually going to run another session on materialized views in Tinybird. We're obviously showing a little bit of that functionality here, but there's a lot that you can do here. And materialized views are a really powerful optimization lever in Tinybird. And if you're starting to scale with Tinybird, or you want to have, the best performance possible, it's really important, I think, to understand how to leverage those. So if you do want that, encourage you to join. I've short linked it there, and I'll leave that up. It's a good session next week. Same time, same day of the week, just a week from today.
Nice. Thank you for doing that. Now I'm going to set up a materialized view. I see we just have a few minutes, but this should just take a second. I'm going to build a new materialized view. I'm going to call this node get reports and parse payload. And kind of like before, this has some important functionality. One is I'm grabbing that payload that comes in with reports, and I'm grabbing the attributes I care about that. I'm also, of course, just grabbing the report type. Event type equals report. I run that, make sure I get what I want there. Now I'm going to create another materialized view. I'm going to call this one reports MV. See if I can type fast enough. And again, going in here, my sorting keys, I don't really care about these so much. I do care about site name, and again, temperature is a very popular type of data to pull. I'm going to go to advanced, and again, just in case I have duplicates coming in, I want to do that. Set it to replacing merge tree, hit next, and let's create that view. And again, what I need to do here is go in, find it under data sources. It's this one. I want to add that tag. So now I can go back and filter and just look at what's related to this part. So I love this new tag feature. It helps me kind of organize my head, my data sources, and my pipes. So there we have, and I can, here we have different documents coming in. You can see that using materialized views, I have a collection of alerts that have their own JSON structure, and I have reports that again has its own. So that, I could do one more quick thing. Now that I have these things I want to serve via an API, I want to serve these reports. So I'm going to call this reports. And what happened there? New empty pipe. Let me take away that. Anyway, I do have one already there. I'm going to rename this something and then come back here. And this will be the final hurrah. So I'm going to create a pipe. I'm going to add a tag. I'm going to call it reports. And then for this one, I'm going to pull in some fancy stuff. I'm going to pull in a bunch of different request parameters, and then we'll be done. So let me run this. First, again, we're pulling from the reports MV, which is a replacing merge tree. I want to use this keyword to get the final look of the data. And here I'm setting up a dynamic parameter for city, also for start time and end time. And if I run that, just to make sure everything's good there, I can create this endpoint. We'll call it that. And you can see here, now I have this endpoint that's serving real-time weather and weather reports, and I can set end times, start times, and a city. So anyway, I think we're a couple minutes over, but that's really what I wanted to get to was that the ability to bring in different JSON objects with different structures, how you can bring them into one data source and then separate the different documents by materialized views. I know Cameron has already shared some links. Here's just another view. And again, yes, join us next Tuesday, September 24th. We'll be digging into materialized views. There's many other types of database table engines that we didn't cover today. We covered merge tree and replacing merge tree, but there's a few others. So want to thank everybody for showing up today, and I hope you've learned a lot of good stuff about pulling real-time Mongo data into Tinybird.
Jim, I'm going to interrupt you because we did actually get a question in about how the object gets Latined. I'm going to let you answer this because I think you can answer it better than I can.
Yeah, let me read the question. Yeah, there's another function. If you have an array of JSON objects, there's a I have to look it up, but there is a specific function for pulling in arrays in JSON and then automatically loading them into an array within Tinybird. And then with that, you can iterate through them. So yeah, there's some more advanced functions for parsing different types of structures, including JSON arrays. So let me see if I can find what that function is. Yeah, here. I'll share one link. But if you Google, I mean, you can start at the ClickHouse layer where they have all different types of ways of parsing JSON arrays. I just shared one example. So great question. Again, thanks everybody for coming today. Hopefully, again, you've learned a lot about different ways you can pull in live Mongo data. I've been super impressed with the real-time nature of it, and the only real trick is once that data lands in Tinybird is finding a way to segregate the different events that happen, the inserts, the deletes, and the updates. The general rule there is like separate those events into their separate materialized data sources. And then from there, you can just go to town. And when you're building data to serve data that could be deleted or was updated, you can use those separate data sources to filter and update that data accordingly when you serve the data as an API. So thank you.
The last thing I'll add, if you do have any questions about what we covered today or about Tinybird in general, please join our Slack community. Got a lot of smart people in there, both those who are at Tinybird and those who have been using Tinybird for a long time.
Yeah, there's
That's a
a
really
lot of
helpful place.
power users hang out there.
Yeah.
So it is an amazing source for learning Tinybird. So thanks, Cameron, for joining me. That was very helpful.
Good job, Jim. All right, everybody.
See you next time. See you next Tuesday.